Saturn, a giant, a gas giant. This majestic planet, adorned with its iconic rings, has captivated humanity for centuries. But Saturn's splendor doesn't end with its rings. Orbiting this gas giant is a breathtaking system of moons, each a world unto itself. Some are icy, others rocky, harboring hidden oceans. This intricate system offers a glimpse into the chaos and beauty of planetary formation. Saturn's moons are not merely passive passengers in their orbits. They are active participants in a complex and dynamic gravitational dance. The larger moons, like Titan and Enceladus, exert a powerful gravitational pull, shaping the orbits of their smaller brethren. Surtur, despite its small size, plays a role in this celestial ballet. Its gravitational influence contributes to the intricate web of interactions that govern the Saturnian system. Studying these interactions allows us to peer back in time, understanding the processes that led to the formation of our solar system. Surtur, with its dark surface and enigmatic nature, is a particularly intriguing piece of this puzzle. Discovered in 2004 using Earth-based telescopes, Surtur is a relative newcomer to our awareness. Its small size and dark surface make it difficult to observe, adding to its mystique. But even from afar, scientists have gleaned intriguing clues about this distant world. Like many of Saturn's outer moons, Surtur is thought to be composed primarily of ice and rock. Its dark surface suggests the presence of organic compounds, perhaps similar to those found on other Saturnian moons. While Surtur itself may not harbor life, its composition and characteristics could provide crucial insights into the conditions under which life might arise. Surtur's story, though still in its early chapters, is one worth telling. The year was 2006. Astronomers, armed with powerful telescopes, were engaged in a survey of Saturn's system. They were searching for faint points of light, for subtle movements, for anything that might betray the presence of a previously unknown moon. On September 12, 2006, the team noticed it. A faint glimmer, a pinprick of light moving against the backdrop of distant stars. This glimmer was faint, easily lost in the glare of Saturn's rings and the scattered light from the planet itself. But it was there, a telltale sign of a celestial object moving under the influence of gravity. The team, led by Scott S. Shepard, David C. Jewett, and Jan Kleiner, had discovered a new moon of Saturn. This discovery, though seemingly small, sent ripples of excitement through the astronomical community. The discovery of a new moon, while exciting, is just the first step. The next challenge lies in tracking the moon's movement, determining its orbit, and gleaning clues about its physical characteristics. The astronomers continued to track the faint glimmer of the newly discovered moon. They meticulously recorded its position night after night, gradually piecing together its orbital path. The moon's orbit revealed it to be a distant one, circling Saturn at a distance of over 22 million kilometers. This placed it among Saturn's outer moons, a group known for their small size and irregular orbits. As they gathered more data, the astronomers began to suspect that this new moon was quite small, perhaps only a few kilometers across. The discovery of Surtur and the subsequent study of its orbit and characteristics would not have been possible without significant advancements in telescope technology. Over the past few decades, telescopes have become increasingly powerful, allowing astronomers to peer deeper into space and resolve fainter objects with greater clarity. In particular, the development of sensitive digital detectors and adaptive optics systems has revolutionized our ability to study the cosmos. Digital detectors are far more sensitive to light than traditional photographic plates, allowing astronomers to detect incredibly faint objects. Adaptive optics, meanwhile, can compensate for the blurring effects of Earth's atmosphere, producing images with a clarity rivaling that of space-based telescopes. The discovery of Surtur is a testament to the power of human ingenuity and our insatiable curiosity to explore the cosmos. With its orbit determined and its physical characteristics becoming clearer, the newly discovered moon needed a name. Following the convention of naming Saturn's moons after figures from mythology, the astronomers chose the name Surtur. In Norse mythology, Surtur is a fire giant, a fitting name for a moon orbiting a gas giant known for its swirling storms. The name Surtur, while rooted in mythology, also reflects the moon's dark and enigmatic nature. Like the fire giant of Norse lore, Surtur remains shrouded in mystery. With a name and a growing body of observational data, Surtur took its place among the ranks of Saturn's known moons. But its story was far from over. In the grand tapestry of our solar system, Surtur exists as a diminutive celestial body. Measurements place its diameter at a mere 6 kilometers. This makes Surtur a dwarf even among its fellow moons of Saturn, many of which are themselves dwarfed by the gas giant they orbit. This small size has made studying Surtur from Earth a challenging endeavor. Despite its diminutive stature, Surtur plays a crucial role in our broader understanding of the Saturnian system. Through studying these small worlds, we gain insights into the processes that shaped our solar system billions of years ago. One of Surtur's most intriguing characteristics is its remarkably dark surface. Observations have shown that Surtur reflects very little sunlight, giving it a low albedo. The darkness of Surtur's surface hints at a composition rich in carbon-based compounds. These compounds, thought to be common in the outer regions of the solar system, are often referred to as tholins. Tholins form when organic molecules are exposed to ultraviolet radiation from the sun, leading to a complex chemical transformation that results in a reddish-brown hue. The presence of tholins on Surtur's surface raises intriguing questions about the moon's history and formation. While our view of Surtur's surface remains limited, scientists believe that it is likely heavily cratered. This assumption is based on observations of other small airless bodies in the solar system, which have been bombarded by asteroids and comets over billions of years. Each impact leaves behind a crater, a permanent scar on the surface that tells a story of cosmic collisions. The size and distribution of craters on Surtur's surface could provide valuable insights into the history of the Saturnian system. In addition to craters, Surtur's surface may also bear the marks of other geological processes. While such features are difficult to discern with current technology, future missions with higher resolution imaging capabilities may reveal a more complex and dynamic surface than we currently imagine. Determining the precise composition of Surtur remains one of the key challenges for scientists. Based on its low density and dark surface, astronomers believe that it is primarily composed of a mixture of ice and rock. However, the exact proportions of these materials, as well as the presence of other trace elements, remain unknown. The presence of tholins on Surtur's surface suggests a significant carbon component. Future missions to Surtur could employ a variety of techniques to determine its composition with greater accuracy. Such missions would not only provide valuable information about Surtur itself, but could also shed light on the formation and evolution of the outer solar system as a whole. Surtur, though small, is not alone in its journey around Saturn. It is one of many moons, each tracing a path through the vastness of space. These moons, varying in size and composition, engage in a delicate gravitational ballet, their orbits intertwined and influenced by their colossal parent planet and each other. The larger moons, with their stronger gravitational pull, exert a particularly noticeable influence on the smaller moons like Surtur. These gravitational tugs, subtle yet persistent, can nudge the orbits of smaller moons over time, creating a complex and ever-changing cosmic dance. Each moon, regardless of its size, plays a role in shaping the system's delicate equilibrium. Scientists believe that Surtur, along with many of Saturn's outer moons, formed not alongside the planet itself, but were captured later in the solar system's history. These captured moons, with their diverse origins, hold clues to the conditions present in the early solar system, a time of chaos and planetary migration. By studying the orbits and compositions of these captured moons, scientists can piece together a history of the Saturnian system, and by extension, gain insights into the processes that shaped our own solar system. Surtur's distant, inclined orbit, for example, suggests that it may have originated in the Kuiper Belt, a region beyond Neptune populated by icy remnants from the solar system's formation. The study of captured moons like Surtur offers a glimpse into the dynamic and often chaotic early history of our solar system. Surtur belongs to a group of Saturnian moons known as the Norse Group, so named because they are named after figures from Norse mythology. These moons share similar orbital characteristics, suggesting a common origin, likely as captured objects from the outer solar system. The Norse Group is further divided into subgroups based on more specific orbital parameters. Surtur, along with moons like Ymir, Loge, and Fornjot, belongs to a subgroup characterized by highly eccentric and inclined orbits. These extreme orbits suggest that these moons experienced particularly chaotic capture events, perhaps involving close encounters with other moons or even with Saturn itself. Studying the similarities and differences within the Norse Group provides valuable insights into the mechanisms of moon capture and the dynamics of the early Saturnian system. Section 4. A Window into Chaos. The study of Surtur and its fellow moons within the Norse Group offers a unique window into a period of chaos and upheaval in the early solar system. These moons, with their irregular orbits and diverse compositions, stand as testament to the gravitational battles that raged as planets formed and migrated, scattering smaller bodies like celestial shrapnel. The very existence of Surtur in its current orbit challenges our understanding of planetary system formation and evolution. Its capture and survival over billions of years speak to the intricate interplay of gravitational forces and the delicate balance that governs the stability of planetary systems. As we continue to explore our solar system and discover new moons, we gain a deeper appreciation for the chaotic beauty of our cosmic neighborhood. Surtur, once a faint glimmer in the darkness, now shines as a beacon, illuminating the turbulent past of our solar system and guiding us towards a more complete understanding of our place in the cosmos. Section 1. A Surface of Secrets. Surtur, like many of Saturn's outer moons, remains largely shrouded in mystery. Its distance from Earth and its small size make it a challenging target for observation, even with our most powerful telescopes. Yet, the limited data we have gathered hints at a world with a fascinating and potentially active surface. The darkness of Surtur's surface, attributed to the presence of carbon-based compounds known as tholins, is a tale in itself. These tholins, formed through the interaction of organic molecules with solar radiation, could point towards a dynamic surface chemistry. While we observe the end result, a dark reddish hue, the processes that create and distribute these tholins across Surtur's surface remain an enigma. Furthermore, while we suspect a heavily cratered landscape, the precise nature of Surtur's surface features remains unknown. Are there vast plains covered in fine tholin dust, or do larger boulders and exposed bedrock dominate the landscape? Could there be signs of past geological activity, such as ice volcanoes or tectonic shifts, hidden beneath the tholin blanket? These questions linger, fueling our desire to one day observe Surtur up close. Within the intricate dance of Saturn's moons, Surtur participates in a celestial phenomenon known as orbital resonance. This occurs when two or more celestial bodies exert a regular, periodic gravitational influence on each other due to their orbital periods being related by a ratio of small whole numbers. Surtur is believed to be in a 3-to-5 resonance with a much larger moon, Bepion. This means that for every 3 orbits Surtur completes around Saturn, Bepion completes 5. This rhythmic gravitational tug-of-war can have subtle yet profound effects on Surtur's orbit over long periods, potentially influencing its eccentricity and inclination. These resonances, while seemingly esoteric, act as a sort of celestial clock, revealing clues about the history of the Saturnian system. By studying these gravitational relationships between moons, scientists can model their past interactions and understand how their orbits may have evolved over billions of years. One of the most tantalizing possibilities in planetary science is the existence of subsurface oceans on icy moons. These hidden oceans, shielded from the cold vacuum of space by thick layers of ice, could potentially harbor conditions suitable for life. While Surtur might seem like an unlikely candidate at first glance, its membership in the Norse Group, known for its chaotic and potentially disruptive past, raises intriguing possibilities. The gravitational interactions between Surtur and its neighboring moons, particularly during periods of orbital resonance, could generate tidal forces within Surtur itself. These tidal forces, similar to those generated by the moon on Earth's oceans, could provide a source of internal heating, keeping water in a liquid state beneath Surtur's icy shell. Furthermore, the presence of tholins on Surtur's surface could play a role in insulating a potential subsurface ocean. Tholins, being relatively dark, absorb more solar radiation than pure ice, potentially trapping heat within the moon. While the existence of a subsurface ocean on Surtur remains purely speculative at this point, the possibility, however remote, adds another layer of intrigue to this enigmatic moon. Surtur, like countless other celestial bodies in our cosmic neighborhood, beckons with the allure of the unknown. While we've gleaned tantalizing hints about its nature from Earth-based observations, true understanding requires a closer look. Future missions to the Saturnian system, equipped with advanced instruments and driven by our insatiable curiosity, hold the key to unlocking Surtur's secrets. Imagine a future spacecraft, its trajectory meticulously plotted, embarking on a daring mission to Surtur. Equipped with high-resolution cameras, this robotic explorer could finally reveal the moon's surface in exquisite detail. We might find a landscape far more dynamic than previously imagined, sculpted by impacts, ancient geological processes, and perhaps even remnants of cryovolcanic activity. But our exploration wouldn't stop at mere observation. A lander, dispatched from the orbiting spacecraft, could touch down on Surtur's alien surface. This lander, equipped with drills and analytical instruments, could sample the moon's tholin-rich regolith, providing crucial data about its composition and history. The discovery of organic molecules, or even hints of prebiotic chemistry, would be a monumental finding, potentially reshaping our understanding of life's building blocks in the universe. The exploration of Surtur extends beyond a single moon. It represents a crucial step in our quest to unravel the mysteries of the outer solar system. Each mission contributes to a growing tapestry of knowledge, revealing the intricate workings of planetary systems. The lessons learned at Surtur can be applied to the study of other icy moons throughout the solar system. These moons, once considered barren, are now recognized as potential cradles of life. Technological advancements to study Surtur will have far-reaching implications. These innovations could pave the way for more ambitious missions, exploring beyond our solar system. The exploration of Surtur represents a giant leap forward in our understanding of the universe. As we gaze up at the night sky, our eyes are drawn to the familiar glow of the moon and the distant twinkle of stars. Yet, hidden from casual view, a cosmic dance of celestial objects unfolds. Surtur, a small dark moon in the embrace of Saturn's rings, captivates our scientific curiosity. Its discovery offers valuable insights into planetary systems. The darkness of its surface hints at complex organic molecules. Surtur's story is a testament to human ingenuity and our desire to explore the unknown. With each new mission, we reveal wonders that expand our understanding of the universe. The exploration of Surtur is far from over. Future missions will unveil its secrets. High-resolution images will reveal its cratered landscape, while landers sample its surface. The search for a subsurface ocean adds excitement. If it exists, it could harbor life. The spirit of exploration drives us forward. Surtur reminds us the universe is full of wonders.